Hello students, in this video we are going to solve the third question about the two tilted disk problem. So if you recollect, this is our problem, and there are two disks which are connected with a rod, which is a massless rod, and it is rotating with the angular speed of omega. First disk has mass m, second disk has mass 4m. First disk has radius a, second disk has radius 2a, and the distance between the origin and first disk center is L, and between the two disks also the distance is L. Now we are going to, and also L they have given as a square root of 24a. Okay, so we are going to try solving, because in the first two videos we have already solved A and B and we found that A is correct. That means the orbital motion, when this assembly starts spinning, it will also start moving around z axis, and the orbital motion, the angular speed of the orbital motion will be omega by 5. That we have already proved. A second question, we have found that this the magnitude of angular momentum of the center of mass of the assembly about the point O is 81 ms square omega, which is not correct. It is coming a little bit different value. Now the third question is the magnitude of angular momentum of the assembly about its center of mass is 17 ms square w at omega by 2. We have found that in earlier second video that the center of mass lies somewhere on this rod here, where this distance between the first disk center and that center of mass was 4L by 5. Okay, so the total distance from O to the center of mass is 9L by 5, that we have already proved. Now we will start solving the second point C. So what we are going to do, find the magnitude of angular momentum of this entire assembly. The assembly has this small disk, this big disk, and a massless rod which connects the two centers. So the assembly about its center of mass, and we found that the center of mass is lying here, which is at a distance 9L by 5 from here, from O. Now we can see here that this spinning motion will make this assembly rotate about z axis, because it is rotating on the xy plane, and we have found that this orbital speed of rotation is omega by 5, right? Now we want to find out the angular momentum of this assembly about its center of mass. Now the orbital angular momentum of a rigid body, because this is a clearly a question, example of a rigid body with its center of mass rotating in an orbit, right? So this particular assembly will have two angular motions. First is the spinning motion, and second is this orbital motion. So the angular momentum about the center of mass, because of the spin motion, will be obviously there, but because of the orbital motion it will be strictly zero. Why? Because we can see that this assembly will move, the entire assembly is going to move around z axis with that w by omega by 5 speed, and there will be no any relative motion, no any relative or angular motion between the center of mass and the assembly, right? When it comes to spin motion, definitely there will be a angular motion of the entire body with respect to center of mass, because this is the axis around which this will be rotating. But when it comes to the orbital motion, the angular momentum of the rigid body about its center of mass will be always zero. So actually we need to only calculate the spin momentum, and that will be the momentum of this assembly, angular momentum of this assembly about the center of mass. So that is explained here. You can pause the video and clearly read this, that there will be a zero orbital component, and hence there will be angular momentum, orbital angular momentum will be strictly zero, and there will be only spin angular momentum which will be given by the moment of inertia into the angular speed. So first we need to calculate the moment of inertia, and then we will multiply it by the angular speed. So the moment of inertia of this disk about its center is the same moment of inertia, right, about its center of mass, because they are having a same central axis, right? And because of that, we are going to first find out the moment of inertia of the first disk, and then the second disk, and then the total moment of inertia, and then we are going to multiply it by this angular speed. So that is, for this we are going to use this, because see, the disk has many moments of inertia. So what we are going to use is the first one, that is the central axis, because it is rotating about the central axis, and we will be using half into m into r square. But there are different other moments of inertia which we can use for other calculations, right? About the diameter, it is 1 by 4 mr square. About the tangent axis, it is 5 by 4 mr square. And all these concepts are also explained properly in this diagram, that this particular disk, the moment of inertia about the central axis is half mr square, whereas that about diametrical axis it is 1 by 4 mr square, and so on. So now we let us find out the moment of inertia about the central axis for the two disks and add them. So it's a simple, straightforward calculations. First disk is the mass is m and diameter, the radius is a. So we will get half m into a square. For the second disk, the mass is 4m, and the radius is 2a. So we will get half 4m 2a square. And this entire moment of inertia will be multiplied by angular speed omega to get the angular momentum about the center of mass. So when you solve this, you will get the value to be 17 a square m upon 2 into omega. And with the right hand rule, if you use the right hand rule, you will find that it is actually going inside, the speed, and vector is going in this direction. I think the rotation is like this. It is going inside, and hence the with the right hand rule, you will get the downward vector for the angular momentum. So you can see this is the same speed. Here I think I have done a mistake here, and actually this is inside, going inside. Okay. So the angular momentum vector will be in this direction, and hence the option C is correct, because the option C clearly mentions the same value, 17 ms square omega by 2, and we are also getting 17 ms square omega by 2, and hence the option C is correct. Now in my next video we will solve the final option, that is option C. So far option D. So far we have got two options correct, that is the first option and the third option. So let us, second option was incorrect. So we will go for the third option in my next video. Thank you.